Okay, this is a video about the introduction of kinematics. It's rather long. Please pause it at various steps in order so that you can take in the information. So, reading the question, a particle P moves in a straight line from a fixed point O, which you're going to call the origin. Its velocity v meters per second after t seconds is given by v of t is equal to 3t squared minus 14t plus 8, for t being between 0 and 4. Write down the initial velocity and find when p is first at rest for t greater than 0. Describe what happens to p for this time t. Find the acceleration when t is equal to 3 seconds. Find the maximum speed of p. Find the displacement of p from O after 4 seconds. And find the total distance travelled in the first 4 seconds. Okay, so we're going to cover quite a lot of points here. Okay, the initial velocity is given when v of 0, so we'll put t is equal to 0 in that, so we get v of t is 3t squared minus 14t plus 8, so v of 0 is going to be 3 times 0 squared minus 14 times 0 plus 8, so that gives 8 meters per second to the minus 1. Okay, make sure you put the units in, so the particle has an initial velocity of 8 meters per second. So for the particle P to be at rest, v of t is equal to 0. So we put 3t squared minus 14t plus 8 is equal to 0. And we have to solve that quadratic. Now, if it's non-calculator, we do product, which is 3 times 8, which gives me 24, and the sum is minus 14. Then we want two numbers whose product is 24 and the sum is minus 14. With a little bit of trial and improvement, we get the factors which are minus 12 and minus 2. We can check that by doing minus 12 times minus 2, which gives 24, and that's okay, that's what we wanted, 24, and then minus 12 minus 2 gives minus 14, which is what we wanted. So we take the first term of the quadratic, which is 3x squared, and then we split the middle term up into minus 12x minus 2x plus 8 is equal to 0. It doesn't matter which way around we write these two. But now we look for the highest common factor of these two terms by grouping them, which is 3t, and in bracket we get t minus 4. Bring down the minus sign, and then group these two together, and the highest common factor will be 2. And when we take the minus 2 out, we must remember to change the sign. We do the procedure correctly here, and here we get the same thing. Now that can now come out as a common factor, so t minus 4, and we're left with 3t minus 2 is equal to 0. So either t minus 4 is equal to 0, which gives t is equal to 4 seconds, or 3t minus 2 is equal to 0, which is going to give t is 2 over 3 seconds. Now we can use the GDC to do this as well, so I'll just do a quick way of doing on the GDC. So go into the GDC and go into a calculation mode and go into menu, algebra, and you should try these steps for yourself. Polynomial tools, finding roots of a polynomial, degree 2 real are the default settings, just leave it as that. Write in 3 minus 14, these are the coefficients, and 8, press OK and press enter, and we'll see we get minus 2/3, sorry, 2/3, positive 2/3 and 4 from the GDC. So there's a screenshot of that. So we take the first at rest at B is equal to 2/3 of S. Right, if we now draw the graph using the GDC, so going back to the GDC and now going back to the home key and selecting a graphing mode and then writing the function 3x squared minus 14x plus 8, press enter. We want a better viewing window than that, so menu, window zoom, window settings, and I used minus 0.5 to here and then to 5 to here, okay, and then pressed OK. Still not the right viewing window, but then I do menu, window zoom again, and then do a zoom fit, and then I get the function nicely on there. Okay, we can find these points of intersection by doing menu, analyze the graph, 0, going to the left of 1 and to the right of 1, and then repeating. Menu, analyze the graph, 0, to the left and to the right. So there's that screenshot. So up the t is equal to 2. Up this particular point here, the velocity goes from positive to negative because it crosses the axis. This is a velocity function. Okay, so what happens there is that p changes direction. At this particular point, because the velocity, the speed is actually changing direction, the object, the particle, will actually change direction as well. Acceleration when t is equal to 3. Okay, so if we want to find the acceleration when t is equal to 3, we have that v of t is equal to 3t squared minus 14t minus 8. If we differentiate velocity, we get acceleration. So acceleration is v dashed of t. So differentiating this function is quite simple. 6t minus 14 and nothing from the 8. And when t is equal to 3, v dash of 3 will be equal to 6 times 3 minus 14, which gives 18 minus 14, which gives a acceleration of 4 meters per second. If we wanted to do that on the GDC, go to the home key and have another calculation mode, and then go to menu, calculus number 4, and then do a numerical derivative at a point. We can change the variable to t, and we wanted 3. We want the first derivative, but you could select the second derivative if you wanted. And then we enter in the velocity function 3t, now in terms of t, because we've made the variable t, minus 14t plus 8. Okay, put that at the end there, and again you can see we get 4. So that's how to do it on the GDC. So if you're going to do it on the GDC, you need to write something down. On the exam paper, you would need to write this: ddt when t is equal to 3 of the velocity function 3t squared minus 14t plus 8 is equal to 4 meters per second squared. Don't forget they're squared. Right, the maximum speed of p occurs when the velocity function is equal to 0. So v dash of t is, when v dash of t is equal to 0, so v dash of t is equal to 6t minus 14. At maximum speed there's no acceleration. So we get 6t minus 14 is equal to 0. T will be 14 over 6, which is 7 over 3 seconds. We want v of 7 over t, so we'll put that, we actually want the speed at the maximum speed, so we'll put that into here. Alright, so the velocity will be 3 times 7 over 3 squared minus 14 times 7 over 3 plus 8. So that gives 3 times 49 over 9 minus 98 over 3 plus 8, which gives 25 over 3, or minus 8 over 1/3. The maximum speed is not negative. This is velocity. We want the speed. Speed is just the magnitude of the velocity. So we want the magnitude of minus 25 over 3, which is 25 over 3 meters per second. So using the GDC, we can get that as well. So going to the GDC, going back to the graph, which is the second one I drew, and then this is the point where the maximum speed occurs, where it's equal to 0. So we'll analyze that graph, and we're looking for a minimum this time, to the left, to the right, and you can see that we happens at 2.33 seconds, but the velocity will be minus 8.33. We just have to, for speed, we just ignore the minus sign. There's a screenshot to show you that. Okay, displacement. displacement is distance in a certain direction from a point. Okay, so all you need to do for that is you need to just integrate the function for all of x, or all the velocity function for all x dt. So st will be from 0 to 4, 3t squared minus 14t plus 8 dt. Alright, you don't need to worry where it goes above or below the axis, just integrate it over the full range. So it would be t cubed integrating minus 7t squared, that's 14t squared over 2, which is 7t squared, plus 8t. When you integrate a constant, you just add in the variable from 0 to 4. So it gives 4 cubed minus 7 times 4 squared plus 8 times 4 minus, now these are all going to be 0, but don't always assume it's 0, minus 7 times 0 squared plus 0. So that gives 64 on the calculator here, minus 112 plus 32 minus 0, which gives a displacement of minus 16 meters. So it's actually gone backwards in the time, 16 minus 16 meters. Okay, if we want to look at that on the GDC, then all we need to do is, because we've graphed the function, all we need to do is integrate the function. So menu, analyze the graph. So integral number 6, put the lower bound at 0, enter, and then roll along. Now you can either go to the point here, or you can write in 4. Okay, as it's at the point, I'm just going to press enter, and you can see we get the same answer, which is minus 16. Okay, you don't need to worry whether it's above or below the curve, you just integrate the function all over the range for the displacement. Right, if we mark on these things which are important, this one's 0, 2/3 is important, and 4. Now for the distance, unfortunately, you can't integrate the function all over its range. You have to integrate it between 0 and 2/3 to get that distance, and then take the absolute value of the negative bit. Okay, so because that will be the total distance we travel, because at the end we'll show you what this particle actually does using a GeoGebra app. Look. So we get t squared minus 7t squared minus 8t 2/3. So just go back to that. We integrate between 0 and 2/3 the function, and then take the absolute value, the positive part of integrating it from 2/3 to 4. Okay, so we've got t cubed minus 7t squared plus 8t from 0 to 2/3, plus the integral of t cubed minus 7t squared minus 8t from 2/3 to 4. Substituting in 2/3, so 2/3 cubed minus 7 times 2/3 squared plus 8 times 2/3 plus, minus 0. When we put 0 in, we already know it's 0. Plus, now we've already done this bit up here. We already know that it's minus 16, so it's minus 16 minus all of that. So we need to minus all of that in square brackets. So 2/3 cubed minus 7 times 2/3 squared plus 8 times 2/3. Right, working this out, we get 60. If we work all this out, we get 68 over 27 plus minus 16 minus 68 over 27. But to do this, all we need to do is add these all together now, ignoring the minus signs. So we need to do 68 over 27 plus that value, plus that value. So what we're doing is we're taking that area and adding the positive value of that area together. So we get 568 over 27, which is 21 and 1/27 of a meter. So on the GDC, we can actually do it straight away as well by graphing the absolute value function of v as shown below. So we'll just go to the calculator again, and we'll go to the home key and select a graphing mode, and you have to go to the template here and select the absolute value one, which is this one here, which I've already selected. Write in the function 3x squared minus 14x plus 8. Take that to the end, press enter. I haven't got a very good view window there, so we'll just set the view window up the same again. Menu, window zoom, Windows settings, we'll set the same thing as before, minus 0.5 to 5. Okay, press OK, and then one more time, menu, Windows Zoom, and then we go to the Zoom Fit. Then we get a reasonable looking graph. And then to do the integral, we do menu, analyze the graph, integral, and we put the lower bound in at 0, enter, and we can either do that or we can enter 4, enter, and you can see we get an answer of 21.04, which is been rounded off as it's a numerical one. Okay, so if we're doing it that way, we need to set up the integral properly. So distance will be from 0 to 4 of the absolute value of 3t squared minus 14t minus 8 dt. That saves you have to work that one out separately and that one out separately if you draw the absolute value function. Maybe you draw that on your exam script. Okay, so that's going to give me 21.04 to 3 significant figures. That will be 21.0 meters. That's the numerical way there. Now the difference between displacement and distance. Remember, displacement is the distance in a certain direction. Okay, so displacement is distance in a certain direction. Distance is the total distance traveled, whether it's in the positive direction or the negative direction. Now we can look at this again. So just get rid of the calculator. I've got this GeoGebra Apps. That's the first thing. That's the acceleration function. You just see it's a straight line. That's the point when we had 3 seconds. We showed it's 4. Okay, so if we click this one, okay, this is for displacement. So moving the thing, you can see the integral changing. So it doesn't matter much. You can see here, up to this point, it's 2.52. Okay, then it'll start getting smaller, but then it will increase again if we take this area here. This is the displacement, which is minus 16. Okay, so we'll just get rid of that as well. And I'll put that back to there, and let's just click for distance. So for distance, again, the first bit's the same, but then if we do the absolute value bit, it will work that bit out again. Okay, that will save you, just go back to this 1 second, having to integrate that and then doing another separate integral of that and adding the two areas together. Okay, this applet will be included in the as a link in the notes of the video. So just look at them both together. So that's the first bit's the same, and then by doing the absolute value function, it starts taking the positive value, so it adds it all up. Okay. Now another way of looking at this is this one here. We've got this particle A at 0. Okay, let's have a look what happens when time moves. So time moves in that direction. Okay, after time gets to 2/3, like we see here, after time gets to 2/3, the particle stops and then changes direction and goes back. Okay, so this displacement gets up to minus 16. Okay, but the total distance travelled is that bit and back again plus that bit there. Okay, just look at that one more time. Again, this applet will be in the notes of the video. So time, it moves off to here, up to 2/3, and then it starts moving back. So displacement gets smaller again, because it's getting closer to 0, but then it goes off in the negative direction. But the total distance travel will include that bit and all the way back to there. Okay, so this has been a video for the introduction of kinematics, and hopefully you can determine the difference between displacement and distance, and you've been able to find displacement and distance from the velocity formula and also acceleration. I thank you very much for watching. I'm very sorry that this was a very long video. Thank you very much.